And live from New York, it's the Desk of Lady Ada.
Plus cat, plus a wild animal. Welcome to another Desk of Lady Ada. It's me, Lady Ada, and on top of me here is MOSFET, the cat mascot of Desk of Lady Ada. Used to be the cat mascot of Ask Engineer, now retired and only doing this show. That's what MOSFET's agent has agreed to. So tonight we got a fun little show. We're going to be doing some step debugging with ATMEL Studio. This is something I wrote a tutorial about earlier today, and so it's fresh in my mind. I thought it would be a good time to go through the tutorial and show you how you can use a proper debugger to debug a processor, a breakout with an ATSAMD21 processor, such as the Arduino Zero. We did a lot of stuff with the Pi Zero. Now we're talking about the Arduino Zero. And you can also do this with the Feather M0s that we have in the store. We have a couple different flavors. Or maybe you have your own board that you designed. Well, I'm going to show you how you can use the ATMEL Studio step debugger. So you can do like memory poking, stepping through, Arduino sketch stuff. It's kind of cool, actually. So that sounds good. And we'll take your questions, of course, in the chat. We have Phil on camera control and also helping moderate the chat. Thank you so much, Phil. And here we are. This is me. This is the bedroom.
Yeah, this is the Desk of Lady Ada.
This is it.
We're
not in the YouTube studio. We're not.
Yeah, we decided not to have a giant studio build out. Last night we did our first show from manufacturing. We moved the show from inventory to manufacturing. That was a big deal. Our promise is we're not going to get a crazy studio. We're just going to continue to broadcast where we are, what we're doing.
This isn't a green screen. This is real.
Yeah, this is not a computer-generated set.
No, this is the real thing. When I say Desk Lady Ada, I'm actually doing engineering.
Yeah. Okay.
It's all genuine. But today we're going to be doing.
Get to engineering already.
I'm going to get. Sorry, let's do this engineering.
Enough jibber jabber.
Yeah. Let's go to the computer. Okay, so this is a tutorial that I just made live. So you can follow along. It's at learn.adafruit.com and it's called Proper Step Debugging for the ATSAMD21 processor. And if you are doing, some of you watching have done hardware only. You started with a 555 timer, and then you maybe graduated to op amps and analog and stuff, and then you maybe did some microcontroller stuff. And you're coming to it from a very hardware based background, and some people are coming to this from I've used an Arduino my entire life, and just Arduino libraries and sketches, and you pretty much just use a serial console, and you've never used a debugger. But some of you are coming to electronics from a software background. It's actually kind of where I'm coming to electronics from. I was actually a computer science engineer person, software engineer first, and then decided to get into hardware. And so it's funny is when you first start programming, you have access to great debugging tools and everything, because when you write code, the code is running on your computer, and so you have access to all the memory and the processor and the compiler is designed for debugging. You really can't do complicated projects on a computer without a proper IDE and debugger. But hardware's been a little bit slower and a little bit more. It's a little not difficult, but you have to put a little bit more effort in if you want to do debugging properly. It's not built into the chip by hand. Often you'd have to use, another tool to do it, because you're not running, an Intel program on an Intel computer. Instead, I've got an ATSAMD ARM Cortex M0 processor. It has its own memory, its own PC pointer. It has its own stack, its own heap. Its own registers, its own architecture. It's completely different than the computer. And so you need to have a way to translate between the two. So if you're coming to this from a software point of view, you're going to really like this, because we actually are using Visual Studio essentially underneath the hood. But if you have no idea what I'm talking about, basically instead of using serial print lines or toggling pins, you will actually be able to go through your code, and at each instruction, every time you do digital write or analog read, you can actually halt and look at what's going on in memory and then continue. This can make it, you can't debug everything, like interrupt stuff if you have interrupt collisions, or switch debouncing, things that are very, very timing based, you may not be able to debug because they're based on external events. But this is still better than nothing, and you can, for some of those things you would use like LED or GPIO toggling, because you can do that instantaneously pretty much compared to this. But it's still a really, really good way to understand, debug, and modify your code and like watch the variables, and especially if you're doing like parsing or you're reading from a sensor, you can look at every computation as you do it. So I think this is kind of neat. So for the Arduino Zero, it actually comes with a chip on it. This little chip, the ATMEL eDebug, which is apparently a AT32U C3A4256. It's a processor that they programmed with their own code that acts like a debugger. You don't have to use, and if you want to use this processor and you don't have access to an eDebug chip, it's built onto the Arduino Zero, which is pretty awesome. But if you don't have that, that's cool. You can use a J-Link. In theory, you can use other SimSysDAP devices, but I think they need to have specific processor command and control. And so far, I've only I plugged in a generic SimSysDAP, and ATMEL Studio didn't recognize it, and it could be possible to configure it. I don't know. I gotta get a tutorial done. I didn't want to spend hours and hours digging into this. Only spent about an hour on it, but J-Links definitely work, and you can get a Segger J-Link from A2Chapter or pretty much anywhere. They are like the de facto standard for ARM debugging, and you can, if you're getting a commercial one, it's about $400, and if you're getting the non-commercial one, it's about $100. It's totally worth it. Totally worth it. I got one in school, and I still carry it with me to this day. And they release firmware updates, and you can upgrade them, so it's worth it. So you have to spend a little bit of money, but I think it's a good idea. Okay, so the chip that we're going to be working with is the ATSAMD 21G18. That's the only one that we're working with. The J-Link code and other stuff will probably work with other Cortex M0 cores, but I don't even have any. So just a caveat, it might work for other chips. This won't work for an Arduino Zero the Arduino Uno or Leonardo, because we don't actually have a debugger that will work with it. I mean, it's possible that the ATMEL made one. I actually don't know if there's a debugger for the 328. I know that there's DebugWire, but I don't know if there's anything that plugs into ATMEL Studio. But this could be expandable. If you find a debugger that pairs with the chip, you probably would just run through what we're doing, but just select the debugger and chip you want. Okay, so to get started, you'll need a couple things. You'll need Arduino IDE installed. I'm using 167. That's pretty easy. Just get that going. Install all the packages as necessary so you can program your chip, like the SAMD package from ATMEL Arduino or from me. If you're using a J-Link, install the software and drivers for it. It's pretty straightforward. You just have to make sure that that's all going. Run J-Link Commander. It's this program that will. Actually, that's not what I want. I want a J-Link configurator. You'll let you update the firmware. I recently did it, but it's kind of handy if you want to make sure you have the latest firmware, which is a good idea. And here's where Mac and Linux people will be sad. You have to run ATMEL Studio 7, and it's Windows-only software. I know. Wouldn't it be awesome? You can sell Parallels if you're running on a Mac. If you're on Linux, I don't know what you can use, maybe VirtualBox or something. But this only works, the IDE is only for Windows. And people ask me, why do you run Windows? It's one of the reasons. A lot of the software is Windows only. Grab ATMEL Studio. Make sure you have a very, very recent version. I actually had a version I downloaded a couple months ago, and it was too old. Make sure you have build. I'm using 790. Have something as good as that. Okay, so here's my warning. When you do this, you're going to blow away the bootloader on the M0 or the Arduino Zero. Not a big deal. I have a section showing you how to put it back on, but just be aware that when you upload through the debug port, you are erasing the chip. It is a raw. It's like using a USB TINI or AVR ISP. You are burning directly the chip, bypassing the bootloader. It's part of the trade-off. But if you're able to upload code, you can just upload the bootloader again, so it's not a big deal. Okay, so let's launch ATMEL Studio 7, powered by Visual Studio. Visual Studio is such a common base for IDEs that chances are, if you've ever done any programming before, you ever do programming again, you will run into Visual Studio. It's really well understood. So, you know, if you get used to it, it's worth learning Visual Studio. And it's a pretty good IDE, you know, compared to some other ones I've used. Okay, so we're going to create a new project and select create an Arduino sketch. And I'm going to call this Blink Debug. And then just use all the default stuff. And then you're going to have to locate the sketch that you want. In this case, I already had this location set up. But basically, I'm going to run the example code that comes with Arduino, and I'm going to run Blink. You can run anything, but Blink is a really good one. It's very easy, it's straightforward. Get this going, and then we can advance. You'll also need to set up the Arduino IDE path, because it will use the Arduino tools to do the compilation. Under boards, you select the boards. It's kind of neat. It actually pulls in all of the board manager files. You want to have Genuino 0. Or, I mean, you could probably use Feather 0 as well, but I would just use Arduino Genuino 0 programming port to remind you. And then for the device, at SAMD21G18, it's already set up, and click OK. Oh, man. Yeah, OK. And then you're going to get invalid pointers. Why? I don't know. Let's quit. I need a debugger for my debugging. I'll be debugging. OK, well, this worked before. Maybe we can get it to work again. Live demo. OK, let me actually open... I'm going to open my old one. Okay, so if you get a pointer error, just restart ATMEL Studio. Okay, so when you load this up, what you're going to see is this is actually the sketch. It's going to be called sketch.cpp because it doesn't use INO files, and you actually have the code here. And this is actually the sketch, which is kind of neat. And there's going to be all this other stuff that is included as well, like Arduino core libraries and stuff. But it actually, like, I don't know how ATMEL did it, but they actually integrated really, really well. So what you want to do now is, oh, can we go to the overhead? OK. So we're going to start by using the Arduino 0. So there's two ports on the Arduino 0. One is the native USB port, and one is the debug port. You really absolutely positively have to be plugged into the debug port because you want to talk to the chip through that eDebug. So let's put this here. Stay. OK, and let's go back to the computer. OK, so now that we have you have to have it plugged in. Go to Tools, and I like doing this just because it's a good way to just verify that you have everything set up, and select the eDebug. Oh, I have my J-Link plugged in, that's why it's like, oh, you can use either, but you plug on the eDebug, select SWD, and click Apply. And it should recognize that the eDebug is working, and then read the device signature, because it's just a very small amount of data that's being transferred back and forth, but it just means that you have your connection right. I don't see why it wouldn't be, but like, you know, whatever. And you can set the SWD clock, 2 megahertz is fine. And then over here, next to Sketch, there is like this setup. And you want to click on Tool and make sure that you have the right setup here as well. So whatever you had before, eDebug, SWD, and the clock, you want that to be set up.
I have the Arduino in the corner right here if you want to.
Oh, wow, sweet, thank you. Yeah, we're going to use it in a second. So now that you have set up, okay, so you're actually like pretty much ready to go. So what we're going to do now is set our first breakpoint. Not going to teach you the full details of how to do debugging with Visual Studio IDE. There are tons of tutorials on how to do it. You can use any software-based tutorial to understand like points and watch points and variable checks. But what we want to do is basically, when we get to this statement here, this digital write, I want to stop right beforehand. So you see here I have a red circle, and I guess you can You can like do conditions and actions and like whatever. It's basically a breakpoint. What I'm saying is, before you execute that line of code, stop. That's it. That's all you got to do. Next, build. And you'll see build succeeded down here. And you can, and I don't have a lot of space on the screen, but you can see the debug output or the build output. And then you can use these tools, but to start, it's always good to see this because you can see what's going on. Let's start debugging and break. So you run this, and you see right here, it's actually, it programmed in all of the code. And now, actually, can we make this bigger or go to this? Because it's really hard to see this little LED.
Yeah, we can just
We want to go to
switch
quad.
from
Yeah.
big to small.
Okay. So you see this debug blinking? That means it's in debugging mode. So you just want to make sure that that's true. Okay. So can we go back to computer view?
With the arena.
Yeah, that's fine. Okay. So we are actually. I will just get this really close. I think that's good. Hold on. Okay, I think this was good enough. Okay, so when you start, you'll notice actually you don't start at the breakpoint. You're actually going to start here at int main, and whoa, don't click that. And if you've never written code before in C, this might be a little weird. You're like, what's main? Main is actually the entry point of all programs in C and C++. And then this actually calls a bunch of functions. For example, if it has USB, it has to initialize the USB. All this stuff happens before your sketch in Arduino actually begins. If you really want, you can step through this stuff, but instead what we're going to do is run continue. And continue will basically set everything up and get you to the first breakpoint. So here we are at the first breakpoint, and it's basically stopped, and like, you can look at variables, like for example, the variable high, and it actually tells you what the value is. It's kind of neat. And what you can do now is you can step line by line. So there's 3 commands: step into, step over, and step out. Step into means for the digital write function, I would go into it, which we're not going to do right now. Instead, what I'm going to do is click step over. So when I click step over, it will, hold on. Yeah, it will turn on this LED, and then it'll go to the next command called delay. And then when I click step over, it'll wait another second. And then if I click step over again, it will turn this off. And so I can step through the commands, and then after it's done with the loop, it goes back and does other stuff. But basically, it turns on and off the little LED. And if I go really, really fast, basically I'm emulating the turning it on and off every second. So that's basically it. Like, you can actually stop right when the LED turns on, LED turns off. This is actually that main loop. So after you're done with, it runs a loop, and then it looks for any serial events, but there aren't any. And that's why you're like, hey, what's going on? Why am I like stepping out? It's because the function ended and it returned back to the main loop. And then you can also do stuff like step into. So if you step into digital write, you end up in another chunk of code, and actually over here, it's in the included core. It's over my head, but it says like, there's included core files and wiring digital. So here we are inside digital write, and you can see, for example, digital write is called with a pin and a value, and we can explore what this pin value is. In this case, it's 13. We know that, but like, let's say you're not sure. If you want, you can also look at the local. Oh, sorry, these are autos. I don't know what autos are, but UL val. So this is 1, and then you can step over each line, and then for example, we got past this section because it is a pin, and next it will. Check if UL val is low. It's not, so it's going to skip this, and it's going to go to setting it high, and then it's going to return. It's actually pretty fast. Like it basically just does that lookup table and turns the pin on and off. This code's pretty simple. Like there's not a lot going on here, but you could easily see how in the more complicated program, if you have a lot of variables, a lot of functions, you want to see whether it succeeds or fails, you can actually go through it step by step. And you can also look at memory, which is kind of neat. You can look at what is going on in each of these functions. So let's step into delay. And, delay has, oh, wait, hold on. Step over, step into. Why it's not? Okay. So you have start keeps track of the tick counts, that's the internal timer. And then it actually just waits. So you see here the start tick count is 8001, and it yields until the tick counter increases. I don't know if I'm actually stopped the tick counter, so that might actually be a problem. I might have to actually tell it to go, because when I'm debugging, the ticker isn't running anymore. So that's kind of basically how to debug. I mean, it's not that hard. You can open up your sketch and basically debug it. So the next thing I just want to show real fast is what to do if you don't have an eDebug chip on your processor. So I'm going to stop this. And just because I'm going to show this before I skip to the next thing. When you did this, you blew away the bootloader on the Arduino Zero. So you probably want to get it back on if you want to use it in the Arduino IDE. So to do that, select board Genuino Zero, programmer, ATMEL eDebug, and then just click Bird Bootloader, and it will do that for you. So that's kind of nice. So my Zero is back to normal. So get rid of this. Okay, so the next thing we're going to do is show the same kind of setup, but using the Feather M0. Some people are like, hey, I have something that isn't a Arduino Zero with that eDebug chip on it, and I have something like this, and I still want to do that step debugging. That step debugging is so cool. So if you have a different, this would apply for any board that has the ATSAM D21 on it. So what you want to do is first locate where the SWD SWD pins are. On the Feather, I didn't kind of expect people would do a lot of debugging. And also at the time, I didn't even know this was possible. So I put them on the bottom as pads, and you just solder 2 wires to SWD clock and SWD IO. And then here's your J-Link. So you've got your J-Link here, and you connect it over USB. And it actually comes out to this kind of gigantic cable, which is okay. It's a large cable. And I actually have a little adapter here that converts it from 2x10 to a 2x5 little skinny SWD cable. Thanks to K-Town for suggesting to get those in the store, because they are, you do need them. And then oftentimes you can actually plug this directly into the processor you're debugging. A lot of times you'll have one of these standard SWD connectors. But if you don't, I have a little breakout as well. I kind of designed all this stuff so that I could use it, and I have it in the Adafruit shop. But that's kind of one of the nice things about being able to do your own manufacturing is it's like, hey, if I want to do debugging, I need these cables. I have 1,000 in stock at all times. I can grab them whenever I need them. Connect ground from SWD to ground here. Connect V-target to 3.3 volts. The J-Link does need to have the V-target set up. And then SWD IO and clock connect to SWD IO clock and data on this connector here. And then I'm just going to power the board through USB. Okay, and cool. So now that that's set up, you have basically J-Link to the adapter, to SWD cable, 2 wires, to the Feather M0. You can go back to, let me adjust this. Okay, so let's go back to computer land. Wrap this up. Okay, so you're back in computer land, and I've stopped running the program. I'm going to check my programming again. So edebug is disconnected, so now go to JLink, apply, and read the signature. Make sure that you have this all set up. If that's all good to go, then in the Blink config, change this also to be JLink and SWD. And now you can build and start debugging in Break. Okay, so again, we're ready, and we are in the main function. I'm going to just fast forward. And can I get the, I'm going to get this USB device recognized because it has a USB, you can't step debug and have USB going at the same time. Like, it's not addressing the USB interrupts. So yeah, this is perfect. So I can do that same thing where I step over, and then the red LED turns on, and then I step and it delays, and then I step and it turns off, and then keep stepping through the loop test, turn on, step, turn off. That's it. So now you're step debugging through the JLink. And like I said, there's probably other tools that you can use, but so far the only ones I've been able to determine that work, that I have on hand, were the edebug and the JLink. But they're also pretty standard, so chances are if you're at all interested in doing this kind of debugging, you're going to have this anyways. So what's cool about this is you can actually, you can run any Arduino sketch that you normally would. You could basically, you can compile Arduino code from within ATMEL Studio, which is neat in and of itself, and then you can turn on interrupts and debug and like see what's going on. So if you're getting like weird sensor readings, or you're not sure why part of your interface isn't working, like you can use this to like stop, probe with your oscilloscope or your logic analyzer or your multimeter, and then continue. So it's like, is this pin really going high or not? Is the analog voltage what I think it is? You can actually like stop and check. So I'm probably going to be using this a lot more because I kind of run into this a lot, and I use the serial console for debugging, which is okay, but like this is so easy. Once you get used to it, you can tell it only takes like 10 seconds to set up and get debugging. It'll make it a lot easier for me to debug libraries. I won't have to like keep recompiling with like different serial printfs or whatever. I would just like upload the code, and then I would step through it and tweak and look at memory as necessary. So that's kind of what I wanted to show today. I thought this was kind of a neat thing. If you have an Arduino Zero, like, why don't you go and try this out right now and like join the thousands of software people who are debugging their software successfully. You can do it with hardware too.
Okay, some not many questions tonight. Mostly feedback. A lot of people really like this. They learn more than a semester of their in school in their C++ class.
Yeah.
A lot of people, I'm just reading a couple other things.
Yeah, sure.
People really like the ATMEL Studio.
Yeah, I mean, I'll be honest, the last time I used a IDE from a chip company was MPIDE, which is the microchip IDE, and it was really challenging. I don't know if microchip people are watching, so I don't want to give my completely honest opinion, but it was definitely not as easy and fun to use as ATMEL Studio. I think ATMEL Studio made the right choice going with Visual Studio and basing it off of this known IDE.
Someone says they were off debugging something, they're back now. Is ATMEL Studio software expensive? And someone said it is free.
It is free. I should have mentioned that it's free software. This is another really nice thing about chip companies. Thank you, ATMEL. It used to be like if you wanted to write code for a PIC, because I started with the PIC 16F84, you would have to pay for Code Warrior. I don't even know if Code Warrior is still around, but you'd pay for Code Warrior, or you'd pay for what was the other compiler? CCS, I think was the name of it. There were like 3 or 4 compilers. Chip companies would basically let these compiler companies target their chips, but you'd have to pay quite a bit, or you'd have a really constrained IDE, and that's actually kind of where AVR GCC made huge inroads, because it was the first time you had a really good professional supported compiler, and then that's what everyone uses for ARM. Basically, they use GCC and for AVR as well, and it's actually worked out quite nicely. So it's cool to see open source actually worked out. Yay! Thanks, Dalman. Nice compiler.
Okay. Next question is, it's over in Twitch. Can you reverse compile the code from the chip, and can you display the processes in assembly too?
That's a really good question. You used to be able to, in ATMEL, look at a decompiled code, not decompiled, but sorry, I don't want to claim it's decompiled, but you could see the assembler. But I only really started ATMEL Studio like an hour ago to write this tutorial. So I don't know how to do that, but it used to be, at least with ATMEL Studio, you could get it to show you the Flash assembly in disassembled, which is kind of as good as you're going to get. There are disassembly tools, and AVR GCC, of course, will give you the intermediate assembler for this. I might cover that in a different tutorial, because I just don't know what click thing I have to click to get where I'm going. This is kind of cool. You can look at the registers and stuff. Memory. Yeah, this is kind of intense, but it is in here somewhere. I just don't know where it is. But you can definitely get it, because AVR GCC has to generate it.
Is there a disassembly window in Visual Studio that could also be in ATMEL Studio?
Yeah, I just don't, like I said, I don't really know Visual Studio. This is kind of new for me. So I'm sure it's under one of the thousands of menu options. I just don't know which one. You can definitely check out like Flash. It's down here, but it doesn't have the assembly output. I don't know. Like, it's uncommon. The thing is, once you get past like an ATtiny 85, it's like once you get past 2K of Flash, it's rare for people to look at individual assembly output. So they probably just say, look, if you're working with a processor like this, you have 256K of Flash, your programs are so big, you're not going to really need to look at the assembler. So they probably hit it.
And that's it.
Okay. Thank you, everybody. Thanks for tuning in for another Desk Gladiator. I like showing off this fun stuff. Getting back, we get the Pi Zero contest is still going on at Hackaday. You still have a couple weeks to enter and win prizes. I think the Pi Zero part might be only a couple more days, but you can definitely get a $100 gift certificate from the Hackaday store. And you have the Hackaday logo on your computer there to remind people.
That's your prize for being a judge for the Hackaday prize.
Yeah.
You were a judge for 2 years in a row. That's what that's for. All right. That's Desk Gladiator. Last night was Ask an Engineer and Show and Tell live from the factory. We'll have some more videos. Today was 3D Hangouts with Noah and Pedro.
And were you doing a 3D? What is this thing here?
This is a 3D camera from Rico. I guess I'm pronouncing that right. Maybe.
Yeah,
maybe
but like, was it on?
Yeah, this is neat. We hacked the camera. You can. There's a SDK. I don't know if it's a hack, but it's more than you can normally do with the camera. And we ran this little PHP thing that allows it to not have all of the beeping, so you can change it that way. iOS app doesn't have volume setting for the beeping. That's why it was really annoying to try to do.
Oh yeah, because we did the beeping.
To try to do that. So
okay.
This is going to be a time lapse 360 that we did, and then that's it.
That's cool, and we'll probably do another stream tomorrow or in the weekend. So looking forward to it. We're gonna get back into some hacking. I want to actually because we just got status page I/O for Adafruit.
You can hook that in all sorts of ways.
I wanted to do an ESP8266 tower light for status page. I thought that'd be really useful. Yeah. So we'll go gonk. Yeah. Whenever Adafruit's down.
Okay. Desk Gladiator is supported by you, the customer. So if you like this type of a live electronics programming, which is the only ongoing live electronics show right now that I know of, please pick up a kit, pick up some electronics, tell your friends. You know, if you see people on Reddit being jerks, tell them stop being jerks.
Stop being jerks, by the way.
Yeah. Yeah, we put more pi zeros in, and there's a current conspiracy that there's actually no pi zeros. It's cool. Like there's full on conspiracy.
Yeah, there's you know what we do actually? Well, it's funny. We retweet and post projects from people who use pi zeros. So like we must have seeded those fake people. I mean, this is a pretty long-standing conspiracy.
Yeah. I've had to deal with people convinced that you don't do engineering. So now I just point to a desk of Lady Ada, and so now you must be computer generated. You're like the hologram.
That's cool. I totally faked that whole thing, by the way.
So, anyways, that's why we broadcast, because we like to talk to the audience and community direct. So, in case you're wondering, a little behind the scenes of why we do what we do. I was talking to a journalist today, and they wanted to do a different type of story. And after explain like what Adafruit's about, it's a cause, it's a business, they're like, okay. So it's kind of neat because it was going to be one of those like, so what's it like turning down funding? It's like we're not really into that. We're not into the startup-y world. It's not like that. We're actually trying to make the world a better place. So there's no like unicorn deal. I can't wait till we're not talking about unicorns. Because like unicorns are really cool.
Who quoted that?
I don't know. Probably like
Anderson or something.
Paul Graham or something.
Paul Graham.
Yeah. Anyways. Okay. Well, that's that.
All right. Thank you, everybody. We'll be doing more of these.
Yeah.
See you later from the desk of Lady Ada.
Yep.
Cheerios. And don't forget, tomorrow, Tony D is going to be streaming.
Yeah.
Raspberry Pi, Bluetooth Energy.
Desk of Tony DeCola.
It is called Desk of Tony D.
That's right. That's right. Look,
he's starting to try.
every single electronics company engineer should do desk of and what they're doing. That's what people want.
It's true.
Trust me. This is what people want. This is what when you meet people and they hear about you, they just want to hang out and see what you do at your desk all day.
I would love to see like Desk of Jerry or Desk of Micah. That would be so cool.
Sure. Yeah, and actually Micah was doing some videos, so I'm looking forward to those. And that's where it's at. So if, it's time. There's high-speed internet. There's HD cameras. It's easy. Back in the day, it was expensive to stream. Now it's free.
Yeah.
We're broadcasting on 5 networks. 5 networks.
Yeah, it's cool.
5 networks.
Yeah, how much was the Twit TV? Because you once looked it up, right? How much did they spend for that whole setup? Like $1 million?
Oh.
The Twit.
Twit, yeah, they spent a lot on their studio. And a lot has changed since then.
Yeah.
Yeah, This Week in Tech, they were like kind of the tech TV model and wanted to turn that into internet broadcasting. And I actually think internet broadcasting is going to be more like this. In the moment, phones, 360 videos, in the moment live and capturing all the cool things as it's happening. And the edit is live. Like, ooh, look, we've got split cam. Ta-da.
You know what? Because actually, I have to watch that movie about Phasm. What was the name of it? Pseudo.
Yeah, we should watch that documentary.
I really got to watch it.
That was across the street from me back in the 90s.
That Pseudo was, it's only a couple blocks from here. Literally, it's down on Broadway. It's less than a mile away from here. We don't have nearly as many drugs, though. Just J-Links.
Yeah. Okay.
I wish we did. Okay.
All right.
We're going to go.
Okay, go, folks.
Later.
Bye-bye.